All right, this is the Chapter 7 practice test. Again, I've said this in class, but obviously feel free to only watch the ones you need help with. If you know how to do number 1, you do not need to watch number 1. Fast forward it, save yourself some time. Let's go ahead and start. Put a circle around the growth functions, put a box around the decay. Now the growth functions are when your B is greater than 1. Your decay problems are when B is less than 1. Now technically it's between 0 and 1, but as long as it's less than 1 for our purposes, we're okay. The B term is always the number that is raised. First one, B term, raised to that exponent. The 3 is multiplied by something, that's not the same. So this one, the B is 3/4, B is 5/4, and B is 1.2. So to go through ones that are than 1. Put a box around the ones that are smaller than 1. 5/4, people see a fraction, so they think it's smaller than 1, but 5/4 is actually bigger than 1. And if you want to find, if you want to use the decimal of that, that's going to end up being 5/4 is 1.25. And this one's bigger than 1, sorry. 1.2, obviously bigger than 1. So, not too bad. Let's move on. What is the y-intercept of this one? The y-intercept is always the number that is in the number that's in usually the y-intercept is 2 for this one. To make sure you're good at, especially if you're not good at math, we haven't done any calculations. We just had to make sure we know what the B term is, what growth and decay was, just a couple of those memorization things. State the transformation. Well, it is an exponential decay problem because it's smaller than 1, but we don't care about that. This -9, the minus 9 means we go to the right 9, and the -7 means we go down 7. Remember, up here is left and right, down here is up and down. The left and right always seems like the opposite. If it's -9, it's actually to the right. If it's +9, it'd be to the left. And then the up and down totally makes sense. I also gave myself a lot more room than on your paper just to make sure I clearly. Evaluate, you're actually, it's almost the same thing as solving. Technically, if I told you like, what's 3 + 4, I would tell you to evaluate that, so that would be 7. But especially for our purposes, the first thing we do with that of 243 is set that. I will tell you from this one on the test, I did not realize this, so your calculators, you can just type in log base. Keep some of your work for this to get full credit. If you just put the answer, I'll give you some points. As strict as I was on the last test, but I need your work to get the answers for this. Turn this into 243. Now we're going to solve this. I will say, technically, if you want to, by taking the log on both sides, you can. In front, so it'd be log of 27, 243. So you can do it that way. That would totally work. The other way to do it, which makes a little bit more sense in this one, or is a little bit easier in this one, is bases. Current sheet, obviously, is not on here. It's a little bit bigger. Change 27 and 240. 27. There's 27. So I know 3 to the 3rd. And again, this one's a little bit more unique. On the test, I'll make sure it's one that's obvious. Like 16, you guys know it's 4 squared, or 8 is 2 to the 3rd, or 125 is 5 to the 3rd. So I'll try these ones that are a little bit more common. 243. So that one, 243 is right here. 3 to x is equal to 3. Both sides by 3. X is equal to, if you want 5/3, you can, or you can round to 2 decimal places, so 1.67. Either one of those is fine. And again, that's the way I would recommend doing it. You could also take the log of both sides. So if you put log of 243 divided by log of 27 in your calculator, that should give you that same answer. Log of 243 divided by log of 27. Yeah, it's the exact same thing. So honestly, for that one, I don't know which one's the best way to do it. It all depends on what you guys want to do, what you're better at is probably a good way to say it. Evaluate log of 10,000. Honestly, this one, the main reason I put this one on the test is because I want to make sure you know that if there is no base, it's base 10. I honestly was trying to make this some easy points for you. So this is log base 10 of 10,000. So again, if you change it to exponents, 10 raised to the x is equal to 10,000. And again, hopefully you can either use your exponent sheet or you can use trial and error. But that ends up being 10,000 is right here. So that is 10 to the fourth. So x is equal to 4. If it's 10 raised to something, however many zeros you have is what the exponent's going to be. So that's 10 raised to the fourth. Now again, not to be a broken record, not to waste your time, but you could have also taken the log of both sides. So it's log, oh, and then put the x in front. So x times log of 10 is equal to log of 10,000. And then divide both sides by log of 10. That cancels, and then put this part in your calculator. So I honestly, again, I think that blue way we did first, I think that's going to be easier for most of you. We've been doing that more often, but we just did a lesson where we did this way. So if that's fresh in your mind and you want to do that, that's completely up to you. State the domain and range for this one. Important things you need to know with this one. The biggest thing is that it does not cross this line. I'm going to try to really close. And it looks like it's right on that line, and that's fine. For every one of these, the domain is all real numbers. For every exponential. The range is where it gets a little bit hairy. So we have y. This one's both, so it's y is less than, and then that line that I said, this one is where it doesn't cross. So everything less than -2 is your range. If it would be above that, it would be greater than. Since it's below that line, that asymptote, the line it can't cross, got to be less than. Like this, equal to x is equal to 6. A couple different ways to do this one. The best way to do this is to realize 4 is 256. Positive 4 is 256. But to get it to be 1, it's got to be 4. We talked about that in class, but every time you have a negative exponent, that just takes, puts into the denominator. So 4 to the -4, it's the same thing as 4 to the +4, just put it in the denominator. That's why it's 1. Solve this one. Again, this is where there's several different ways to do this. 125 is 5 to the third. Actually, let's do, sorry, let me take a step back. Those that have the same bases, obviously 125 squared is way bigger than 625, or 125 raised to any exponent. So we're going to have to change both of the bases. So 125 is 5 to the third. If you need your, you can use that. But then is 5 raised to, right here, 625. So that's to the fourth. So that's 5 to the fourth. So we end up with 5 raised to the 3x is equal to 5 to the fourth. And now we put those exponents equal to each other. Divide both sides by 3. X is equal to 4 over 3. Or again, you can use your calculator, make that into a decimal, 1.33. Now again, is if you took the log of both sides, so log of 125 to the x is equal to log, oh no, I'm going to run out of room. Let's do this way over here instead. So 125 raised to the x is equal to 625. So x times log of 125 is equal to log of 625 both sides by the log of 125. Better give you the same exact answer. Let me check real quick. Log of 625 divided by log of 125 is same thing, 1.33. I don't know which way I'd recommend. It depends on which way you're better at. We've been doing this way a lot longer, but this one's a little bit more calculated work. So whatever you want to do, either one works. Just please show your work. That's the biggest thing. Number 9, write this as a single algorithm. So the first thing I have to do, simplify, is I put these multiplication up as exponents. So this is log 3, 5 to the third plus log 3 to the sixth. Now I will say this is simplified. People on their quiz solved this one or evaluated this and got like an answer like 10 or 15. That's not what I'm asking for. I want you to simplify it. So make sure you're paying attention to that calculator, and that's why they solved and simplify. So that is log base 3 of 125 plus log base 3, 2 to the 6. You can use your calculator. 2 to the 6 would be 4. And since it is plus now, we multiply these together. So log base 3 of 125 multiplied by 64. That's a bigger number, but that's okay. 125 times 64 is 8,000. So log base 3 of 8,000. That is the answer I'm looking for. Again, a couple people took this and said like 8.18. If you put that in your calculator, that's not what I'm looking for. That's evaluating it. I want it simplified, not just evaluated. All right, moving on to the next one, number 10. So we're solving this one. Now there's a couple different ways you can solve this. I think this is going to be the easiest way. It's equal to the log of 9. I mentioned this before. If you look at these, they both have a log on either side. So if they have a log on either side, the left and the right, we're going to try to make it so it's one log on the left and one log on the right, which I know it is, but putting that, simplifying that, using the 2 the exponent helps. These are both base 10. So actually the logs cancel. And then take the square root of both sides, and the square root of 49 is positive 7. Now, if you put plus or minus 7, I'll give you credit for that, but it's not technically, it can be negative 7. If you're curious on why that is, if you let me know, I can talk to you about it. But I don't want to confuse you or waste your time here. So number 11 is done a little bit differently because we have the logs on the same side. So we're going to supposed to be a plus. Yes, sorry, this plus sign right here, I need to change that. And the reason I made a mistake because when you're adding those, you multiply. So 5 and x 2. So log of 5 times x plus 2. I put them in a different order, but that's because we're used to seeing it that way. Apologize, that should be changed. So that 5x plus 10 is equal to 3. And this is where, 2 or 3 times where I get to this, maybe made a mistake. Remember, this is log base 10. So remember, if you only have the log on one side, we're going to eventually put in exponent form. So we only have the log on the left-hand side. This is all together. So if we put that together, we have 10 raised to the third is equal to 5x plus 10. And now we can solve this just like any normal problem. So 10 to the third in your calculator is 1,000. Subtract 10 from both sides. We end up with 990, I believe, is equal to 5x. Divide both sides by 5. I get x is equal to 198. So again, that should be a plus sign, not a multiplying. But again, the reason I messed that up, not that it's justified, but when you add, you multiply those two together. So I multiplied these two. And then again, when I got to this point, I got confused because do I take the log of both sides? What do I do? No, if there's a log on one side, you just put it in exponent form. That's going to make your life easier. Number 3, solve this, round to 2 decimals. 3 raised to the x is equal to. The first thing I'm going to do is take the log of both sides. Things you could do, but using log at base 10, so just using log is going to make life easier. That makes it so you can put that exponent first. So x times is equal to the log of 85. Divide both sides by the log of 3. And then you can put that in your calculator. Log of 85 divided by log of 3 is 4.04. X is equal to. Now I will say, when you type this in your calculator, if you write it as a fraction in your calculator, it's going to be different, but I always use it as division. So for me, when I put that in my calculator, it says log, and right when I hit the log button, it puts in this parenthesis, and then you put in 85. You have to put this other parenthesis before you hit the division sign. Divided by the log of 3. And again, now at the end, if you want to put a parenthesis in, you can, but that doesn't matter as much. But if you don't put that parenthesis, your calculator is going to read this as the log of 85. Sorry, the log of 85 over the log of 3. And so that's going to mess that up real bad. So if you put it in your calculator as division, I would definitely say make sure you remember the log of 85 comes first. That goes in parentheses and then divided by the log of 3. These shouldn't be too bad. Put this in exponent. Raised to the x is equal to 12. Again, my biggest thing is to realize that these are not going to equal the same thing. The log form and the exponent form. And then my base is always going to be my base. So my base of my log is the base of my exponent. So if you accidentally did 8 raised to the 12 is equal to x, I know that's wrong because they cannot be equal to the same thing. It's got to be 8 raised to the x is equal to 12. Right? Same thing with this one. If you put log and it's base 6, but if you said of x is 215, I know that's wrong because these two are not equal to the same thing. That's not the idea. So this has got to be log base 215. Whoops, dyslexia. Is equal to x. Hopefully those are getting pretty second nature by now. We've done that a bunch, but just in case you need some review. All right. Now remember, the things that I check for graphing is the I put quotes around it, the y-intercept. The reason I put quotes is it's going to start with the y-intercept, but then we're going to move it up, down, left, and right. And asymptote. You cannot always starts at 0, move it up or down. Can't cross line, the asymptote goes at the y-intercept for this one. That y-intercept is the number in front. We don't have a number in front. This 1.2 is the base number or exponent. That is not the y-intercept. That's telling me if it's a growth or decay. That's not telling me. So there is no y-intercept. It is just a line. So that's where we're going to start at. 3. Right? 3. Sorry. 3 is 1, 2, 3. 1, 2. That's my y-intercept, and that's why I put the parentheses. It's not really a y-intercept after we moved it. If we move that line to the right, if we move that line, literally do it. We move that line to the right, 3, 1, 2, so that line is right here. Don't erase paper, but just to make it a little bit more clean. So that's what we're using the graph. Now, the only other thing I look for is it exponential growth? And what does that graph like? What's the shape look like? So if you drew shape, I'm giving you points. So this one, exponential growth problem, because it's bigger than 1. That means it starts low and higher and higher. Make sure you do not cross that yellow asymptote. That's very important. Now the other one, again, we're starting with the asymptote at 0, and then this one, the y-intercept is this number right here, so that is 2. And then again, that's where we're moving. This -1 means we actually go to the right one. So my new y-intercept is here. My asymptote, if you go to the right, doesn't change at all. It still stays right there. And this is exponential decay. So it starts up here. As you go down, you have to make sure you cross right at my new, again, y-intercept, quote unquote. And then don't cross that line. You can get really close to it, but don't touch it and don't cross it, please. Evaluate these. Again, these equal to x, and then put these in exponent form. 5x is equal to 625. We're already using it. You could take the log of both sides at that point. That will work as well. So log of 5 raised to the x is equal to 625. Take the x in front. X log of 5 is equal to log of 625. And divide both sides by log of 5. Again, I'm not saying this way is easier by any means. Whatever you want to do, but that should give you the exact same answer. I personally would do that first way. Again, the big thing is, though, you need to make sure, because, again, I just found out you can put that in your calculator and just get the answer. So I need to see something, whether it's stuff over here, whether it's this thing, whether you take the log base 5 of both sides and use a different property, whether you use the natural log, whatever you do, I need to see some work, because I don't want you to just put that in your calculator. X, so that 4 raised to the x is equal to 8. Remember, you cannot make this base 4 because 4 raised to what number is 8? There is none. It's going to be some decimal. So instead, I'm going to change 4 into 2 squared raised to the x. And 8, I know, is 2 to the third. 2x is equal to 2 to the third. Base, so set the exponents equal to each other. 2x is equal to 3. Divide both sides by 2. X is equal to 3 over 2 or 1.5. I do not care which one you use. Now again, then taken of both sides. Move that x in front, so that's x times log of 4 is equal to log of 8. And divided both sides by the log of 4. That cancels. You should get the same answer. For what it's worth, this is actually, this if you show your work this way, that's actually something called the change of base formula, and it means that you can change the base of any logarithm. If you do it that way, I'm not going to get into it because we don't use it very often, but that is a property that does exist. If you're interested, totally talk to me and I'll tell you. Again, this is one of the people mess up on the quiz. Some people like each one individually. So they said that this one was 3 to the third is equal to 27. So they said this part was 3. This part was 4. So they said 7. Now it's very awesome. You can do that. That's not what I'm asking for. So that's not what I want you to combine this. That's log. That's the answer I'm looking for. And the next one, same thing. You're going to put that 5 up here as your exponent. Maybe that's the answer. Maybe I should put more of them with variables because you can't do those in your calculator. That's not a bad idea. So this could easily be this on the test where this is an X instead of an 81. Again, it actually makes it easier if you know how to do it using the way you just be X, so it should be 26. You wouldn't even multiply anything. It's not a bad idea. So this next one, that 5 goes up as an exponent, so it's log base 6 of x to the 5th, and that's literally all you can do with that one. That's all you need to do is simplifying. If this was a number instead of an x, I would appreciate if you did. So if it was like log base 6 of 3 to the 5th, I would appreciate if you simplified that 3 to the 5th and put 243. But if it's just an x, you can't really do that. Um, 21, express this as a single logarithm and then evaluate. More lenient on the quiz where some people evaluated each one of these to them. So if you do that during the test, I'll probably be okay with that. But the way it's covered in the class is divide since it's subtraction. 1536 divided by 3. So if you take 1536 divided by 3, $12. 12. So that's the single logarithm is equal to x when we evaluate. 8 raised to the x is equal to 12. Again, if you want to, the way you do it, if you want to take a log of both sides, you can. This one, if you look, 8 does not have, never mind. I was going to say 8 doesn't have 5 12, and it does. 2 to the third is 5 12. So that means x is equal to 3. And if you want to take the log of both sides, tremendous, but you can do it. 8 log of 8 x log of 8 is equal to 5 12. And divide both sides by log of 8. Give you the exact answer. Now, I think when I was doing this, what I did, this says express it as a single logarithm and evaluate. So I think when it's a quiz, x is equal to 3, I gave you points for that. But if the way you found that, you said, you can't do it on this one. All of them, one we just did earlier. Yeah, this one, like I just said, some people, when it said this 3 raised to the x is equal to, evaluated each one individually, and that one was 3 and this one was 4, so they added them. So some people did a similar one like that to one of them down here. This one you can't do that. 8 raised to no number is 1,536. So it's a little bit different in that respect. I should remember that. So the next one, we are doing compound problems, compound interest problems, and the formula P raised to the RT. Formula, I'm not going to make you memorize it, but you have to know what it means. A is the final amount. P is the principal, and that's the starting amount. E is the number. That's just a number. It's 2.7 or something like that. R is your rate. Remember, that's always going to be a decimal. Can't fit it in there. Decimal. And T is the number of years. It's the time, but for our purposes, it's going to be the number of years. So I will give you this formula. I'm not going to give you any of these, so make sure you know what everything means. Okay, so invested $7 into that has 7% interest, compounding continuously. Again, that is important, but all we've done is compound continuously, so you don't really have to much after 15 years. Is what we're looking for. What the is. My P is what they put in. We don't worry about that number E. That's just in your calculator. R is 7%. Remember, 7% is 0.07. Don't put 0.7. A lot of people make that mistake. That'd be 70%. If you have a bank that gives you 70% interest, then let me know because I'm going to retire right now. And T is the time, and that's 15 years. So go ahead and put this in. It is equal to my E raised to the R times T. From here, now you can put that in your calculator. If you don't know where the E is in your calculator, let me know, preferably before the test, but I will help you out with that. So 4,000 raised to the 40. And depending on how you do this one, is 11430, 60. I rounded two decimal places since this is mine. So $11,430.60. Answer to this one. In most of your calculators, your Casio calculators, it makes this look like an exponent. If that's the case, then that's perfect and that's great. In my calculator, it doesn't. It looks like this with that caret symbol. If that's the case, you need to put the 0.07 times 15 in parentheses. If you don't put that in parentheses, it's going to give you the wrong answer. But again, I really don't think you guys have to worry about that because most of yours, even if you have a graphing calculator like mine, most of them nowadays, you put it, it actually looks like an exponent. So as long as those are both up with the exponent, the 0.07 and the 15, shouldn't be a problem. Next one, again, I always start by putting my variables over here. RT. My goal is 100,000 in my Roth IRA. So 100,000 is your final amount. That's what you want. I put $8,000 into the bank. 5%, so 0.05. The years are that, well, I have $100,000 in the bank. So we equation up, and A is equal to P raised to the RT. Is equal to 8,000 is the beginning part, the beginning amount, E raised to the R. First, we need to do get rid of this 8,000 since it's multiplied and divide. There's 12.5, I believe. E raised to the 0.05 T. So under this point, now E, I'm going to take that natural log. Okay, you can use the log base 10 property, the common log, work, but this one's really nice because it's a shortcut. You can cancel that right away, and over here, all you have left is 0.05 T. So then just divide both sides by 0.05. Natural log of 12.5 divided by 0.05. Again, you might have to make sure that's in parentheses because I'm going to do it. 50.5. If you round to one or two decimal places, I'm okay with that. I would say round to the nearest number, so I do 51. Moving around here, let me zoom back in. Solve the following exponential equations around to two decimals if necessary. Again, there's several different ways to do this. Since we already have the same base, we can set the exponents equal to each other. And or solve that. 17 is plus 17. By both by 2, you get x is equal to 11. Now again, there is a way you can do the log of both sides. Log of 6 to the 5th, is equal to, then take the log of the other side, 2x minus 17. Take those in front. 5 times the log of 6 is equal to 2x minus 17. Log 6. And then you have to do this. Actually, I'm trying to see. I know you can solve it that way, but it's a nightmare. Trying to think what the best way, because then I guess, yeah, divide by a log of 6. And then you do the two-step from that, 5 log of 6 over log of 6. You would add 17 to that, and then you divide by 2. Anyway, it's a nightmare. You can do it that way, but it's terrible. I would not recommend it. Let's just say if you want to do it that way, or I guess if what I was doing, all that huge mess, you were following along with that, then sure, you can do it that way. But if you got lost, then certainly don't do it that way. Well, again, if you want to do the log of both sides, you can. The big deterrent for me is that we have variables up here with my x's, and we have an x on both sides. Both of those things make me think that I'm going to try to stay away from using the logarithm properties on this. Can I change or raised to something? Get this and clean this up a little bit quick. Thing 1020. So that's 4 raised to the 5th, x minus 3, is equal to 4 to the 5th to the x plus 1. Now, again, I mentioned this on the people still missed it. You have to make sure you distribute that. So 4 to the x minus 3 is equal to 4 to the 5x plus 5. 3 is equal to 5x plus 5. So subtract 5, subtract. Negative 3 is equal to 4x plus 5. Negative 8 is equal to 4x. Running out of by 4. X is equal to negative 2. For my next problem. We only have one variable on the left, and there's no like up here there was other stuff. We had x plus 3 and x plus 1, so we didn't just have the variable all by itself. This one it is. So this one I'd say whichever way you want to do it. If you want to use the bases to be the same, is there 3 raised to some number that's 729? So 3 over here, so we're good. It's 3 to the 6th. X is equal to 3 to the 6th. X is equal to 6. If you want to do it that way, that's fine. This is another way. If rather, you can take the log of both sides. And again, I'm not saying this is easier, but I yellow, that was terrible. I had to pause it and cry a little bit, but I'm kind of crying. Okay. And then divide both sides by the log of 3. Again, that will give you the exact same answer. So honestly, in blue, I think that takes longer. I think that's harder. But the good news is, if you do the log properties this way, you'll always be able to do it. If you look at number 27, you can't do number 27 the way we did this one over here. So let's go ahead and start on that. So on number 26, I was able to find that 3 to the 6th was 20. So let's try that with, so 5 raised to what number is 500? So 5 is right here. There is no 500. We're already too big. It goes from 125 to 625, so that doesn't work. But option 2, can we make both of those smaller? So can I make 5 into 2 raised to something or 3 raised to something? And the answer is no. There's no number I can make that if I raise it to an exponent, it's going to be 5. So the only option for this one is you have to do it with the log properties. This is going to be some decimal. So we do the log of both sides. And that makes that exponent move in front. That's the whole key with this one. And again, I know this is a little bit more work, but it's not too bad. Ultimately, it's a lot of writing, and it is calculator work. So log of 500 divided by log of 5. Log of 500 divided by log of 5. Again, be careful with your parentheses. You're using division. So I end up getting 3.8613. That's 3.86 when you round. The log on both sides, so I'm going to simplify first. So to the third, raised to 343. Sorry, no, I have that much room. Both log base 7, those, so x to the third is equal to 343. It should be on here. So here's the deal with this one. So here's the mistake I made. Sorry, I was not thinking correctly. I was not thinking the right headspace. So I accidentally thought this was this one. 3 raised to what number is 343? 1. It's a decimal. But that's not 3 raised to the x. This is not number is 343. To the third is 343. So instead of what I was doing, look at this, now I'm find 343. A mistake. I'm supposed to put 243, but it's because it's not that way, it's the other way. What number to the third power is 343, so you're going to go down this column. Is 7 to the third is 43, so x is equal to 7. The other way to do that one real quick, and you guys should know this from last chapter, exponent sheet, I'll be okay with that, or take the third root of we have x is equal to is 7. So we get the same answer. I personally like that second way that I just did in orange, mainly because I almost messed up this other way. And this one, now there's a log on one side, and we have to combine those, not a log on the other side. So this one's going to be a little different than the one we just did. So since you're adding, we're going to multiply those. So log of 15 times 5x is equal to 2. Confused, and this has happened to me a couple times now. Remember, if there's the log just on one side, we're going to put an exponent form. So 15 raised to the 2. 15 raised to the 2 is equal to 5x. Is 225 is equal to 5x. Then just divide both sides by 5. That ends up getting x is equal to 45. My answer key is wrong, so I'll fix that. Okay, so I'm sure I made a mistake somewhere in here because there's a lot of work, so what surprised me, I did find some mistakes from my answer key, so hopefully if you're looking at those, like the one on this one, it has x is equal to 15, so that's not right, so I'll change that. Hopefully by the time you see that, it'll be changed. Again, make sure you remember, you will get, I think I'm going to give you guys an exponent sheet, but somewhere on the top is going to have a is equal to PE raised to the RT. You're not going to know, I'm not going to put what those stand for, I'm just going to put the formula. Ultimately, again, make sure if you know how to do all the problems on this practice test, then you will at least not be surprised on the test. You're not going to get any problem you don't know how to do. I'm not saying you'll get them all right. You might make some simple mistakes, but you're going to get a problem like number 29. And since you did it on the practice test, again, you might make a silly mistake like I did and put 15, but you're at least not going to be able to see that and say, and just put IDK. So make sure you do the practice test. That's where, again, I have a lot of students that have told me they're trying so hard to do well in this class, and I've had guidance counselors that say, the student tells me they're struggling and they're working really hard, and the first thing I look at is your practice test. Because if you're not doing your practice test, it shows me you're not really working that hard, because that is the most important homework assignment that's going to help you on the test. I'm not telling you to skip your exit tickets, but this is going to help you on your test more than those exit tickets. All right. If you have any other questions, obviously let me know.